Welcome all. Thank you for tuning to my channel. I invite you to a mathematics lesson. In the former lesson, we discussed how the area of a segment can be calculated, the area of a sector calculated, and we also know how to get the area of a triangle which is in a sector of a circle, such that now we use the area of the whole sector minus the area of the triangle, we can get the area of a segment. In other words, when we got a circle like this, and we have a sector, then in this sector we got a triangle which can be extracted like that. For us to get the area of this segment, this is a segment, we said we take the area of the whole sector, then we subtract the triangle, and by subtracting the triangle from the sector we get the segment. Therefore, with that idea now of getting the area of a segment, it can lead us to calculate the area of the section in between two intersecting. When a circle intersects with another, there is an area which has been created in between them, and it's what will be in this session. Therefore, let's follow an example, because already we know the formula of how to get the area of a segment, and we will see how the area in between two intersecting circles can be calculated. Therefore, you're given an example like the figure below shows two circles and A and B. So with two circles, one with a smaller radius and another one a bigger radius. So given a circle like this, then we are told there is another which is now having a bigger radius, and they are intersecting. They are intersecting in this manner, two circles, different radii. The first one has A, the other has center B. Then we are told that the radius for this one is 6 centimeters, and the radius for this one is 8 centimeters. 8 centimeters. So we can now elongate this to there. We are told again the two circles meet at P and Q. Then this one is subdivided such that angle PAB is, and the angle ABQ is 30 degrees. 30 degrees like that. Then this area now may drop a line here. PQ is a very perpendicular line. Yes, we have that line there. But now this area is shaded. This area is shaded like that. Then we are told to calculate the area of part 1, sectors PAQ and PBQ. Also calculate the area of triangles PAQ and PBQ, and lastly calculate the shaded area. Then we are told to take pi as 22 divided by 7. 22 divided by 7. Therefore, this is the question. I would like us to solve it. Systematically. Let me get a calc solution now. Part 1. Calculate the area of sectors PAQ. the sector with center A. Therefore, we said that the whole angle, first of all, at A, the angle PAQ will be 42 by 2, giving us 84 degrees. Therefore, the whole of this angle is 84 degrees. Therefore, now to get the area of sector PAQ, we shall have the angle all over 360 pi r, which is 6, squared, which is 6 times 6. Therefore, we shall have 84 by 2 times 6 times 6. Then we divide by 360 multiplied by 7. So this gives us 26.4 square. For the first sector, PAQ, will be that way. In the next one, the angle at PBQ will be 60 because PBQ will be 30 by 2, giving us 60 degrees. Therefore, now we shall use 60 degrees divided by 360 multiplied by pi r squared, so 8 by 8. This will give us the area of the sector PBQ. Therefore, we shall have 60 by 22 by 8 by 8, divide by 360 by 7, and this gives us, just a minute, 60 by 22 times 8 times 8. Then we divide by 360 by 7. This gives us 3.52 square centimeters. Therefore, the area for this sector now is 33.52. Roman 2, we're getting the area of the triangles in each of the sector. So for triangle PAQ, area of a triangle is given by half one side times the other side times the sine of the angle in between them. The sine of the angle in between them. Therefore, half times 6 times 6, sine of 84. 3 by 6, sine 84. And this gives us 17.90 square centimeters. So the area for the triangle in the first sector is 17.90. The other PBQ, it shall be half times 8 by 8, the sine of 60. And this will give us 4 by 8, sine 60, 27.71. So the area for the other triangle in this sector will be 27.71. And lastly, we thought to get the shaded area. Therefore, it is good to realize that when we extract the first triangle, the first circle, which is having center A, like this, then we have this line here. Taking the area of the sector and we subtract the triangle, we will get this segment. Therefore, taking the first sector minus the triangle in, we will get the segment on this side. And again, taking the second sector minus the triangle inside, we will get the segment on the other side. And therefore, adding the two segments will give us the shaded area. Will give us the area in between. Therefore, the area at the center shall be, when we take the first sector PAQ, and we subtract the area of triangle PAQ, we will get the segment there. And after getting the segment there, we add, when we take the other sector, PBQ, and we subtract the triangle in PBQ also, then we will be getting a segment, and we add them. They are giving us the shaded area. Therefore, when we take 26.4 minus 33.52, we will get the first segment. Then we add, when we take sorry, let me arrange the things well. The first sector, and we subtract the triangle in it, 17.9. The triangle in it is 17.9. Then we add the other sector, 33.52, and we subtract the triangle in it, 27.71. Then we add, we'll be getting a segment, then we add. Therefore, 26.17.9 26.4, and we subtract 17.9. Then we add 33.52 minus 27.71. This gives us 14.31. Square centimeters. So that's how we get the area which is in between two intersecting circles. So that's how simple it is. Provide a question now which you will try during your own time. Just a similar question. You go and try during your own time. So a question is here. It says the figure below, two circles, center C and D. So this is a question now for you to try later, because we have already seen how it should be done. So we got a question saying two circles, just like the ones we done, with center C and D. Then they are meeting at A and B. Then we are told that given that part A, okay, the radius we have 8 centimeters, and this one 10 centimeters. That's provided. Then we are told that area triangle ACB is equal to 30.07 square centimeters, and triangle, the other one is ADB. ADB is equal to, for triangle ADB is 43.3 square centimeters. Now with that, find the size of angle. Find the size of angle beta and this other angle. Therefore, we have this angle abbreviated, that symbol. Then the other angle is beta, like that. Then after that, we told part B, calculate 2 decimal places the area of, calculate the area of part 1, sectors ACB and ADB, and lastly Roman 2, the shaded region. So that's the question. Make sure you try it during your own time. Thank you for following. Subscribe to Shifting Grades and share our links.